Okay, this is going on page 98 when we are done. So today is going to be an introduction into how to find missing sides of a triangle when it is not a right triangle. So we're going to come up with this from what we know about right triangles. So I want you to look at this triangle here under where it says law of sines. And we are going to, since it's not a right triangle, we are going to break it up so we can make it into a right triangle. To draw in this perpendicular segment here, and we'll call that H for the height. And I want you to notice some things here on how this is labeled because this is important. Capital A, capital B, capital C, they represent points and also the names of the angles. Then you have lowercase a, b, and c because they are side lengths. Okay, that again is something that I stressed heavily in geometry because some of you just think you can willy-nilly make them, you know, capital, lowercase, whatever. It makes a difference. They mean different things. And notice that side A is across from angle A, side B is across from angle B, side C is across from angle C. Like that's important too. So what we're going to do is we're going to start and we're going to find, we're going to use angle A and angle B here, and we're going to set these up with sine. So I'm going to find the sine of A. So the sine of angle A is equal to the opposite over hypotenuse, that is H over B. And then I'm going to solve for H. So I'm going to multiply both sides by B, and I get H is equal to B times the sine of A. Okay. And because these two right triangles that I have that I've split it up into, they share H. Okay, so this is going to be helpful to me. So then I'm going to find the sine of B. So the sine of angle B is equal to the opposite, which is H, over the hypotenuse, which is A. So again, I'm going to solve for H. So H is equal to A times the sine of B. Okay, so now I'm going to do a little, oh, that should be a capital B. I'm going to do a little substitution here. Okay, I am not setting them equal to each other because that would mean I'd have these two equations literally set equal to each other. It makes no sense. I am substituting, and since H equals A times the sine of B, I'm going to substitute this part in right here where H is right there. So that's going to give me A times the sine of B equals B times the sine of A. Okay. So now what I'm going to do is I want to leave the signs in the numerator. I'm going to get fractions out of this. So I want to move this A. So I'm going to divide both sides by A. The little a, and those cancel out. So now I have the sine of B is equal to B times the sine of A over A. But I would like to get rid of B on the right-hand side, so now I'm going to divide both sides by B, and those cancel out. So what I have now is that the sine of angle B over the length of B equals the sine of angle A over the length of A. So this is important here because if I look over here, this triangle, in the end, although I used H to come up with my right triangle stuff that I knew, I don't actually need that length there. If this is gone, then I have this triangle that is not a right triangle. I can find, if I know this angle, this side, and this side, those are 4 pieces. If I know 3 of those 4 pieces, I can find the 4th. And that's how the law of sines works. Okay, so I don't have to have a right triangle. I don't have to worry about, I don't even have a hypotenuse or anything else like that. Now, because this works, if we were to draw the height in differently and do all the work, then this would also be equal to the sine of C over C. Okay, so it all works out nicely. This is what your law of sines looks like. The sine of angle A over the length of side A equals the sine of angle B over the length of side B, which equals the sine of angle C over the length of side C. This is a super easy equation to remember. And this whole thing, it is possible that you could see it with the signs on the bottom, but as long as they're all on the bottom, it's just the reciprocal of this and then it totally works fine. Okay. All right, so when using this, and when we do law of sines, there's also law of cosines, which we will get to. We're using some properties from geometry. When we found congruent triangles, okay, so your congruent triangles, it says, the law of sines can be used to find the side and angle measures given two angles in any side. And so basically it's the application of angle, angle, side, angle, side, angle. Because if you know two angles and a side, then everything has to just work out however it would for every triangle that has those same two angles and sides, because all those triangles should be congruent. We had other triangle congruence theorems and postulates. So this was two of them, and then we also had side, 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 angle, side, and HL. Okay, so these will come later. Today, these are the only two that we're looking at. And then it does say, or two side lengths and an angle outside of them, which is this one, which if you remember, that is not a congruence theorem or postulate because there's no ass in geometry. But it ambiguous is, and we'll talk about that when we get to it. But we're going to start with the first two, the angle, angle, side, or angle, side, angle. So it says, find each missing measure, round the answers to the nearest tenth. Ooh, I forgot to change that. You know that shouldn't be the tenth, that should be the thousandth. All right. So if you're given angle, angle, side, or angle, side, angle. Now, right now, that's all I'm giving you because that's all we're able to do at this point. But what you should figure out here is whether or which one you have, so you know whether to use the sine or the law of sines or law of cosines, or maybe if it's the ambiguous case. So I do have two angles that I've been given, and that's great, but I've got two angles, and then I have not the included side, right? This would be angle, side, angle here. So I have angle, angle, side. Since it's angle, angle, side, that tells me it's law of sines, which again, it's the only one we know right now, so we know that has to be it. So I have the sides and angles that are related to each other. 104 is across from x, 47 is across from 15. So I can say that the sine of 104 divided by x is equal to the sine of 47 divided by 15. Okay. So then when I do this and I cross multiply, right, I'm going to multiply x times the sine of 47, and that would be equal to 15 times the sine of 104. And then I want to solve for x, so I'm going to divide both sides by the sine of 47. So x is equal to 15 times the sine of 104, divided by the sine of 47. So you want to be very careful here on the calculator, and when you type this in, you can put it in there. I'm going to try really hard to make this something you can see. When you type this in, I would do it in a fraction. You can use parentheses, but on this calculator you can do it in the fraction. So I'm going to start with my fraction. So hit my little fraction button, and then I'm going to do 15 times the sine of 104. I'm going to close my parentheses. You have to close the parentheses. Then I arrow down to get in the denominator, and I'm going to type in the sine of 47, close my parentheses. And I actually didn't have to do 15 times the sine. I could have just stuck them together. But so that's what I have on my paper. That's what I have there. Then I can hit equals and get my answer. So make sure that you can do that. And what you get in the end then is that x is equal to 19.901 centimeters. Let's look at number 2. This is it's angle, side, angle, because the side is in between the two angles. So I have angle, side, angle here, which means I get to use the law of sines. And so I have 42 is across from x, so I can say the sine of 42 over x equals, so this side length is across from this angle. I don't know what that angle is, so I got to find it. It's very easy to find. I'm going to add these two together and subtract from 180. That is something that you should be capable of doing without a calculator. However, since you do have one that you're allowed to use it so you don't mess up on something easy. And you get 75 degrees here. So that means I take the sine of 75 over 28. So then I cross multiply. I'm going to get x times the sine of 75 equals 28 times the sine of 42. So that means that x is equal to 28 times the sine of 42 divided by the sine of 75. So we type that into the calculator. Go ahead and do that. Don't wait for me to come up with an answer. I get that x is equal to 19.397 feet. So make sure you agree with that. That's what we should get. Okay. So the same things happen on 3 and 4. I don't know that we need to necessarily do 3 and 4, but let's go ahead and look at number 5. Okay, so it says a pilot begins a flight. Hang on, wait for it to catch up with me here. Maybe. There we go. All right, so a pilot begins a flight traveling 80 miles northwest. To avoid a storm, he makes a turn, then returns to his original location. A diagram of his flight course is shown to the left. Find the total distance of the flight. So right now, we're not having to draw the picture of the flight plans, but we are going to have to eventually do that. So he starts here, and then goes here, makes a turn, and then he comes back. All right, so all we're really looking for, it says find the total distance of the flight. So we have to find both of these pieces, and then we have to add it up. So I'm going to label the side links, since they're not labeled with anything. I'm going to call them x and y, so that I can have something to look at. I'm also going to need that third angle, so we can go ahead and find that. 108 plus 15, subtract from 180. Get what that is on your own. $57 degrees. Okay, so I'm going to find the total distance, which means what I'm going to do here is I'm going to store my answers in this calculator so that I don't necessarily, so I don't have to keep it as exact, because these exact answers, they're not horrific, but it takes a lot of typing in. So I'm going to find them, but I'm going to store them, and I called them x and y. I can store them in my calculator on under x and y. So you start with this. The part I have to use is I have to use these two for sure to get started, because that's where my two pieces of information are. And I'll start with x, because, you know, it comes first, why not? So x goes with 108, so I can have the sine of 108 is equal to, not equal to, dang it, sorry. Sine of 108 over x equals, and then got to use these because I can only have one unknown, the sine of 57 divided by 80. Okay, so I cross multiply, x is equal to, or not x is equal to, dang it, x times the sine of 57 is equal to 80 times the sine of 108. That means that x equals 80 times the sine of 108 divided by the sine of 57. So I'm going to type that in the calculator. I'm going to put that 80 times the sine of 108 divided by the sine of 57. And I'm going to store this number because I'm going to need it. So I'm going to show you my calculator here. So this is what I typed in, and notice this time I did not put the times in the numerator, which is fine. So it really does look exactly like what I did. But this is my x, so I want to store it in x. So remember to do that. You're going to hit the shift key, recall for store, and then my x is above the right parentheses, so I just hit that, and it has stored it in x. And if I'm unsure, I hit the AC button, and then I can do recall x, and there's my number. Okay, so let's go write that down. Now, this is not my final answer. This is a piece to the answer, and I'm going to have to use the stored answer for it. So x is equal to 90.72 blah, blah, blah. I'm going to put little dots there. That's kind of my reminder not to use that rounded number, but that it's in the calculator. I have the value, I have a concept of what the value is, so I can see if it's even a reasonable answer, which it is. All right, so then I need to find y in order to do this. So the sine of 15 over y is equal to, and I'm going to use this same thing. I'm not going to, I could use my stored values, but it's safer to use what they gave you. Equals the sine of 57 over 80. Cross multiply, y times the sine of 57 is equal to 80 times the sine. So y is equal to 80 times the sine of 15 over the sine of 57. So I'm going to type that in. I'm not going to show you this time, so make sure you know what you're doing here. So I do 80 times the sine of 15 divided by the sine of 57. And then I'm going to store that in y. And what I got was y equals 24.68 blah, 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 right? I'm not even estimating the 3 decimal places so I don't accidentally use it. It says the total distance. The total distance is what I want. So my total distance of the flight, right? He flies out here, makes a turn, and then returns. So basically it's the perimeter of the triangle is what I'm looking for. So my total distance is just 80 plus x plus y. And that's what I can do in my calculator. I do 80 plus recall x plus recall y, hit equals, and I can say that the total distance equals 195.409 miles. Now, could I have avoided storing and just typed in this plus 80? Absolutely. That works too. There's nothing wrong with that. Just as long as you're using the exact values or, and not rounding along the way, then you're good. Okay. So let's flip it over on the back. So then it says, watch out, when finding angles, it's possible to have one solution, 2 solutions, or no solution, okay? So when finding angles with the law of sines, it's possible to have one solution, 2 solutions, or no solutions. So this is the ambiguous case. This is why angle side side does not work when you're talking about congruent triangles, okay? Because if I have, you don't have this picture drawn, but you can draw something like this. See. So I can look at this triangle here, the A, I guess we could call this point D. We'll call that D, so we have something to call it. So this triangle ACD and triangle ACB have something in common. They both share side AC, so it's congruent to itself. And then they both have this CD and CB. These sides are congruent to each other. So this is an isosceles triangle right here. And then this angle right here, it belongs to both of those triangles also. So they share this. They share that angle. And then because this is an isosceles triangle, these 2 little angles here are congruent. And so if you have these 2 sides and the non-included angle of this triangle is congruent to these 2 sides and the non-included angle of the bigger triangle, those 2 triangles there, not congruent. It's definitely possible, but it's why it's called the ambiguous case, because maybe they're congruent and maybe they're not. But that's going to require us to check some things as we go through these problems and we work them. So I want you to see that this angle here, that's either like this little thing, this side right here could swing over here, it could swing back, but the angle, the bottom angle here of either triangle, it's either going to be this angle, because that's this angle right here, or it's going to be the angle that's supplementary to it. So the angle is either angle B, this one would be 180 minus angle B, and that's going to play a big part in what we're doing with this, okay? So let's look at these important facts. It says the sine function always has a range between blank and blank. So I want you to think about that. Like the sine of pi thirds. What is the sine of pi thirds? It's the square root of 3 over 2. Okay? That is less than 1. right? Because square root of 3 is less than the square root of 4. The sine of pi sixths is 1/2. It's also less than 1. When you go to pi halves, it's negative, or it's 1. And then when you're at 2 pi or at 0, it's 0. So, and then you can go all the way around to -1. So the sine function always has a range, because it's y values there, between -1 and 1. That's important. It's always between -1 and 1. And if you remember that sine is opposite over hypotenuse, has to be less than 1 to make sense in a triangle, but it can equal 1 or -1 on the circle. So it says angles with positive sine functions, or function values, lie in quadrants blank or blank. Well, everything's positive in quadrant 1. And then think about all students take calculus. That means the sine values are also positive in quadrant 2. Okay. So let's think about what that means. This angle would be acute. This angle would be obtuse, right? It's somewhere between 0 and 180 when we're talking about in degrees here. To find the other possible angle, so if I say this is one angle, what's the other possible angle? Remember, these have to be supplementary, right? These two angles here are going to add to give me 180, so I would have to subtract from 180 degrees. The sum of the angle measures in a triangle is always, now, always when it's a Euclidean triangle, if you remember for a spherical triangle, it wasn't this, but it's always 180, something we need to know for this. And no triangle can have two obtuse angles. Not possible. Okay. So let's do a couple of these examples. We're going to start with number 6. Okay. And I don't have a picture, so I need to draw one. Do I know exactly what this picture is supposed to look like? No, I don't. And if all your pictures kind of look the same, it's fine. You just got to get something to label. So I'm going to draw a triangle. And I'm going to make this angle A, this angle B, and this angle C. So then it tells me that the measure of angle A is 60 degrees. So here's my 60 degrees. The length of AB is 30 inches. The length of BC is 27 inches. And I want to find the measure of angle C. So we'll put a theta there. All right, so this is your two sides and the non-included angle. So this is your side-side angle situation, which tells you you use the law of sines. However, it's the ambiguous case, so you're going to have to check some things. All right, so let's go ahead and get this set up using the law of sines. So I'm going to take the sine of the angle that I'm looking for, so the sine of theta over the length of this opposite side, which is 30, is equal to the sine of 60 over the length of the side across from it, which is 27. So I need to get the sine of theta by itself. And so I'm going to multiply. I could cross multiply here, but when your unknown is in the numerator, it's way easier just to go ahead and multiply both sides by 30. And so this is going to give me the sine of theta is equal to 30 times sine of 60, 27, right? And you could put all of that in the numerator if you wanted to. So when we go to find this, we actually need the sine inverse of all of this, but I would think that it's really going to be better for you just to kind of do this all in the calculator at this point. So let's type this in and see what is happening. So I'm going to have 30 times in my fraction, and it was the sine of 60. Close my parentheses over 27. Hit equals, and I get this, but I really want my decimal here. Okay, so this decimal, is this my answer? Is that my angle measure? And the answer to that is no. That is the sine of theta. So I need to get theta. If the sine of theta equals this number, then the sine inverse is what I'm going to get from theta. So I want to take the sine inverse of this number. So I'm going to do shift sine, and I want it of the answer, so I hit the answer key down there by equals. Sine inverse is what I got. And it's going to give me 4 degrees. And so let's write that down. We get that theta equals 74.207 degrees. But remember, this is the ambiguous case. So it could be this angle here, or this could swing in here, and maybe it is the obtuse angle. Remember this here? So like, let's say that this is 74. So it could be 74 degrees, or it could be the angle that's supplementary to that 74 degrees. And just like it says here, to find the other possible angle, subtract from 180. So we subtract that from 180. So in your calculator, you can do 180 minus that last answer. And so we get this angle, and we also get 105.793. Now, these may not both work just because it's the ambiguous case. Remember, it also said that you could have 0, 1, or 2 angles. So maybe neither one of these actually work. So let's think about how we can look at this. If I take this angle here, theta could either be 74 degrees or 105 degrees, right? And so if I add that to 60, I would add it to get my third angle. So I have to see if this is even possible. So if I take 60 and I add it to that 74.207, that value right there is less than 180 degrees, which means I have room to subtract to actually get an angle. So this angle works. Then I'm going to take 60, and when I add that to 105.793, I don't even care exactly what it is, but that's going to be like 165 point something, so that's also less than 180. So that one works, which means this is one of the cases where we have 2 answers. Okay? All right, so that's how that one works. Now let's look at number 7. Let's start off the same way. I'm going to draw my picture. I'm just going to draw a triangle where I have room to label things in there. And I'm going to make this A, B, and C. And I have that the measure of angle C is 89 degrees. The length of AC is 34 meters. The length of AB is 26 meters. And I want to find the measure of angle B, so that's my theta. Okay, so I have it all labeled. I look at this and I have 2 side lengths and the non-included angle. So this is a side-side angle situation, which tells me I'm using the law of sines, and it's the ambiguous case. I'm going to have to check stuff in the end. So I start off by setting up my law of sines here. I'm going to find the sine of theta. So the sine of theta over the side length 34 is equal to the sine of 89 over the side length of 26. So I'm going to multiply both sides by 34, so I get that the sine of theta is equal to 34 times the sine of 89 over 26. So let's go ahead and type that in. Do 34 times, and your fraction is the sine of 89 over 26. So I'll give you a second to get that typed in. When I type that part in, and I'm going to write it down this time. I didn't last time because I don't want to click back and forth. But what I have now, when I hit equals, I get 1.307 blah, blah, blah. So I get the sine of theta is equal to 1.3074 blah, blah, blah. But even if I rounded to 3 decimal places, I wouldn't then use that. So I have to take the sine inverse of that number. So just like I did on the last one, I'm going to do shift sine and hit my answer key, which is next to my equals key. Hit equals, and it says math error. So I wonder, did we do something wrong? Think about, did we do something wrong? If so, what is it? Or does it make sense that I get an error here? Because remember, we could have 0, 1, or 2 solutions here. Let's look back up at what it says. The sine function always has a range between -1 and 1. You are never going to have a sine value that is greater than 1. Never. Or less than -1. So this right here, because this just doesn't even work, this thing doesn't even make a triangle. Okay? So in this case, once I get this, and this can't equal anything, doesn't work, the answer is no solution. There you go. So that 89 degrees isn't big enough or small enough for this side length to actually create a triangle. So it's like this, maybe this side length with that angle measure and the other two side lengths might stop there. So it's not actually going to create a triangle. That's why you would get the no solution type thing. All right, so let's look at number 8. I'm going to start the same way. I'm going to draw and label a triangle. Draw and label. So this is A, B, and C. Then it says that angle C is 102 degrees. All right, well, guess what? That doesn't look like an obtuse 102 degree angle, but it doesn't matter. I'm not going to redraw it. Totally doesn't matter. So the length of AC is 21 yards. The length of AB is 24 yards, and I want to find the measure of angle B. And so that's my theta. So I'm going to set up my law of sines. I'm going to take the sine of theta over 21 equals the sine of 102 over 24. So the sine of theta is equal to 21 times the sine of 102 over 24. So go ahead and type that in. So when I do that, and I'm going to write it down, I didn't the very first time, I did the second time, but I'm going to say, okay, well that means that what I got in the calculator, sine of theta equals 0.85 blah, blah, blah. So at least that 0.85 number right there, that's between -1 and 1, so I'm good. So I have that, so I have a reasonable idea of what's happening, and then I'm going to take the sine inverse of that, so shift sine answer, and I get that theta is equal to 58.857 degrees, and then remember I can subtract it from 180, so 180 minus the answer. My other option here is 121.143 degrees. Now, just because I have these does not mean that they both work, so I have to check it. So remember, I'm going to take this 58 degrees and add it to 102, so 102 plus 58.857. So when I do that, that's going to be 160 something. That's less than 180. That's all I care about, so that means it works. When I take 102 and I add it to 121.143, well, guess what? That's greater than 180 degrees. And if these two angles together already have more than 180 degrees, then there's no room for this angle to happen. So this one does not work. Plus, remember up there it said that you can only have one obtuse angle in a triangle. So since this is already 102, this obtuse one is totally not going to work. And this is my answer here. But part of your answer is showing that this one doesn't work. Like you have to find it, and then you have to show that you checked it. And not just that, oh, you stopped at that one and you got lucky. Okay. I will tell you, we're not going to work number 9 and 10, but if you feel like you need to go back and work them, then I'm going to give you the answers, and that way you can go back and work them and see if you get what you have. You end up with 38 degrees and 142. This one doesn't work, so this is your answer for number 9. You can go back and work them, but not right now. And then on 10, you would get that x is equal to 31.189 degrees and 148.811 degrees, and both of those work. So there are those answers. We are going to work 11 though. So 11. I'm going to start by drawing and labeling a picture once my board catches up. Oh, come on. So here's my triangle. It's going to be A, B, C. So the measure of angle B is 125 degrees. So once again, it doesn't look obtuse in my picture, but it does not matter. The length of BC is 24. The length of AC is 21. And I want the measure of angle C. Well, I can't directly find the measure of angle C because even though I do have two sides in the non-included angle, this theta that I'm looking for is across from this side that I don't know. This 24 is across from this angle that I don't care about, but I'm going to have to find. So theta is used, I'm going to use alpha, which looks like the puffy Jesus fish. All right, I'm going to set that up. So I'm going to have the sine of alpha over 24 is equal to the sine of 125 over 21. So that means that the sine of alpha is equal to 24 times the sine of 125 over 21. So I'm going to type that in, 24 times the sine of 125 divided by 21. So I get the sine of theta is equal to 0.93 blah, blah, blah. I don't really care about writing that down, but remember, that's just the sine of the angle. You need to find the angle, so you have to do the sine inverse of the answer. And then that gives us that, oh, I want to put theta. Dang it. This should be alpha. Let me fix that. Sorry, I'm used to doing theta, but we named this one alpha because theta is the other one. So this is the sine of alpha. Alpha, which means your alpha angle is 69.419 degrees, or I have to subtract that from 180, 110.581 degrees. Now, in the end, I want theta, not alpha, but I have to finish the whole process with alpha before I can worry about theta. So these are the two options. I got to check them to see if they even work. And if they both work, then I move on to find two answers for C. If only one of them works, then I move on to find one answer, whatever. So I'm going to take this 125, and I'm going to add it to 69.419. Well, when I do that, well, 120 plus 60 is 180. So this is greater than 180, and this one does not work. That's a big no. When I take the 125 plus 110.581, that's definitely greater than 180. So that one doesn't work either. So since neither one of those work, then the measure of angle C is not possible. I can't find it. No solution there either. Okay? But I didn't get the no. So what would have happened if I could have found theta directly, and it still would have been no solution, then my sine value would have been greater than 1. So that doesn't show up on this one right away like it did on number 7. But that's why you have to check both of them every time, because it's not always that one of them is going to work. So go ahead and glue or tape this in.